Alrighty, folks. Today we are going to go over the last couple weeks worth of work you've been doing regarding minerals, and we're going to make sure you have the right answers, understand why maybe you got something wrong, so on and so forth in these mineral identifications in order to get you ready for the mineral practical. We'll also give you some tips, some tricks, and hopefully what to expect. Sorry? Yes. Practical is what we call a test in lab. Great question. So, and I do bounce back and forth between calling it the mineral test and the rock test and the rock practical and the mineral practical. I try to use the proper words. But yeah, practical, it comes from like practicum. You might hear about nursing students doing their practicums and whatnot. It's just a hands-on lab test. And that's a great segue, actually, to what to expect. So you guys here on campus, you'll be locked out in the hallway here. It's 9 o'clock. I'll try to get here early so I can get it set up. Otherwise, you might have to wait a couple minutes for me to set it up. You're going to come in, and there's going to be just a hunk of mineral set at each one of these seats, okay? Little foreshadowing here. There's going to be 25 of them out. I'll explain that later. So you literally, and you're going to get a blank piece of paper with 2 columns on it. First one is mineral name. Second one is mineral group. All right. Mineral group didn't get a whole lot of attention, but I did tell you it's really, really, really important. It's half the mineral test. So, anywho, you're going to walk in and you're going to come to the first seat, let's say, and say, oh, that's a hunk of sulfur. It's an, what group, you guys? Elemental. Good. You're going to move over to the next one. Oh, that's rose quartz. It's a silicate. That's all you got to do. No formulas, no properties, no nothing. You folks at home, you're going to see pictures. All right? I doubt, I'm working on making 3D models. I was just talking to the students here about it. I really don't think I'll have all the 3D modeling done by then. And you didn't learn on them, so it might not be a great idea to switch for the test. But ideally, we'd like to get away from these static images that you guys see. You know, it's almost 2025 for crying out loud. We should have 3D stuff. But it's actually really hard to do. I have to take 3 to 4 dozen pictures of each specimen and then let it process it. And I'm still not even sure if D2L will allow me to display it. I might have to put them on a separate site and then you link to them. We'll see. We'll see. But it's a neat idea. So you guys are going to see pictures just like this, and here on campus, these guys aren't going to be allowed to use their identification tables. There's no tools. You're not going to have your steel nail with you or anything like that. So we expect the same thing of you guys at home. And a word of caution, Google Images is not very good at taking this test. Okay, I've seen the results it gives. So when you're sitting at home, please don't drag the images into Google image search. It doesn't work very well. You might get some of them right, but not most of them. And then when you give me these mineral names that we never even talked about, I totally know you're using Google. So, anywho, don't cheat. All right. These guys here, it's really hard to cheat because they're a couple inches from me, but it's just you, yourself, and your brain. Okay. So that's the test. You get 25 minutes. It is timed. Doesn't sound like a whole lot of time. You're like, oh my God, that's 1 minute per specimen. Yeah, but if you know what it is, how long does it take to write down orthoclase feldspar? And I picked a long one there, right? Orthoclase feldspar. Yeah, a couple seconds. So if you go into the test prepared, a minute is way more time than you need. I let you move from specimen to specimen however you want to. You guys at home, you could click back and forwards as many times as you want to. The only thing I ask is that there's not more than one person at a specimen at a time. Don't camp out at a specimen hoping to Jedi mind meld with it, okay? You just, if you don't remember what it is, maybe you'll see another one further down and it'll remind you. Oh, okay, that one was that other thing. And just go from seat to seat to seat. Remember, you know, for those of you writing down on actual paper, the hardest thing is not starting at 1 if you sat down at like 12. Okay? Makes it really hard to grade. So make sure you're writing at the number you're actually sitting at. We got a lot of you in here this time. Again, I love to see a full lab, but it does make it a little tighter on test days. You know, when there's only 6 or 7 of you sitting here, well, you could roam all over, not a problem. So you guys are going to have to be a little more syncopated and so on and so forth, but it'll work out. At the end of the time, or whenever you're done with the test, whichever should come first, you put them in up here at the top of the on my desk. You go out in the hallway, you wait for everyone to finish up. Once everybody's done, we come back in. And you sit down in your groups, and we go over them. Back in the olden days, we used to pass the test back, give it to your neighbor, let's grade them, see what you got, kind of thing. We're not allowed to do that anymore. HIPAA, FERPA, one of the two. Okay, and I get it. That's fine. But in going over it, you guys just took it, 4.5 minutes ago. You tend to remember what you wrote. So you'll leave having a pretty good idea of how you did on it. You folks at home, of course, you get immediate feedback. So that's nice. Any questions about the format of the test? Oh, and then you get to go home. It's a short lab next week, or whenever we take the test. All right, it's a short lab day. Questions about the format of the test? There is no word bank. I will put the mineral groups on the board. I don't count spelling. As long as you don't write orthoclase like labradorite, I'll probably count it. Okay, give me ortho something, and you'll probably get the point, especially if you call it a silicate. Speaking of which, the columns are separate. Okay, so it's 2 points per question. So if you call it the right name but the wrong group, you'll get the group right, or the name right but the group wrong. If you call it the wrong name and the wrong group, you'll lose both points, okay? Try and dissuade random guessing. Because let's say you call it sulfur and it's actually olivine, and you put down silicate for the group. Don't try to argue that, well, olivine was a silicate. Well, good, yes, you're right, but you called it sulfur, and you're trying to tell me that sulfur is a silicate. So that doesn't happen too frequently unless you're going in totally clueless, all right? But more often than not, this rule benefits you guys that I grade them separately. So, again, questions. And you folks at home, feel free to email me with questions. Okay, let's start talking about these. So you guys have them lined up in front of you. You folks at home can't do that, obviously, so I am going to scroll through your gallery here as we talk about them. Okay, so numbers 1, 2, and 3 all have something in common, and that's that they're all members of what family? Not mineral group, but they're all different kinds of whatses. They're all different kinds of quartzes. Good. So we got 1 here. We got 2. I only got 1 picture of 2 for some reason. And then here is 3 for you online folks. So one of them's pink. One of them is sort of white, and one of them is clearer and pointier. What do we call number 1, you guys? Crystal quartz. How about number 2? Milky. Good. Which leaves 3 to be rosy. Good. All right. So on the test, I need to see first and last name for anything. All right. You're not very likely to write just rose or crystal, but just a heads up, I need to see rose quartz. Why do I say that? Well, because you might be very likely to write orthoclase. I need to see orthoclase feldspar when we get there, okay? Biotite. Nope, I need to see biotite mica. So I need to see the first and the last names on these guys. All right, so anyhow, 1, 2, and 3, off to a great start. Number 2 gets chert a lot, okay, until you guys actually get to chert. And then you're like, oh, that isn't, this is chert. This is a whole lot chertier than chert. So chert looks very unique. These are much glassier vitreous, okay, as it were. 4, 5, and 6 also have something in common. And they are all members of what family? These are all feldspars. Good. The blue came out really nice in this picture. Look at that sucker glow. You guys haven't seen it too good on your in-class specimens. So we got this pinky peachy colored one. What did you guys call that? Orthoclase. Good. The whitish, sometimes grayish one. Albite. Good. And then the dark gray, but we got a really good blue flash on here. Labradorite. Good. All right. So you got 3 feldspars. There's a lot of feldspars out there, just like there's a lot of quartzes. We just picked a couple to look at. Orthoclase and albite are going to show up over and over and over again when you guys get to igneous rocks. All right. Again, they use slightly different names like we saw on the Bowen's Reaction Series stuff that we talked about in class. But it's essentially orthoclase and albite. And like I said, sometimes you'll see this albite isn't quite as white when we get to igneous rocks. And this orthoclase isn't quite as, I like dusty salmon. I don't know what you guys called it, but that's my color name for orthoclase. It looks a little paler sometimes. But there's a lot more going on. These are pure mineral chunks that we're giving you. Now, I've been talking about families. We've got something else, though, called the mineral groups. And so far, all 6 of these are examples of what? The silicates. Good. All right. All these first 6, and actually what? The first 12 are silicates as well. Just looking ahead. Seven and 8 also have the same last name. We'll be done with this kind of last name thing soon. 7 and 8 are both examples of something called a what? Micas. Good. You have a light colored one and a dark colored one, and trust me, this is relative. Okay. When you are, especially here on campus, don't look at these specimens on the shiny black tables, especially if it's sunny out that day. Put them on your test. They're going to be in little boxes. Keep it on that flat white thing, all right, because these micas in particular, boy, they reflect like crazy, and it can affect the color. I try to put similar things next to one another so you guys can compare and contrast, all right, but sometimes muscovite can look awfully dark or biotite can look awfully light, so it's a nice thing to always be able to compare them. So that being said, 7 is muscovite mica, and 8 is biotite mica. Good. Biotite, easy. B, black, brown. B's. Remember the B's. Oh, and I didn't say that for the albite. Bite, teeth, white. So, I don't got anything for orthoclase orange. I don't know. But, got to find these little tricks that'll hopefully help you. Speaking of little tricks, when you're studying, don't line these up in order like they are right now. Because think about it. On test day, what's your actual goal? Your actual goal is to figure out which of the 12 clearest white ones this actually is. So kind of group them by color when you're when you're studying, okay? So put all the clearest white ones sort of in a pile, put all the dark gray ones in another pile, and so on and so forth. Because that's what you really have to do with your brain is sort out which one of the ones that it looks like are you actually looking at. So, all right. 9 and 10. Wow, this 10 came out, looks a little different in person. I must have used flash on this one here. 9, one of the distinguishing factors is that it has these very long needle-like crystals. Almost looks like black toothpicks lined up and all stacked together. What did you guys call 9? Hornblende. Good. Hornblende. And then 10, you're not really seeing the black in this picture very well, but it's black and green. This one just kind of looks shiny green. But blackish green and grainy, what did we call 10? Augite, okay? Now, on paper, these guys look very, very, very similar. Their formulas, their structures, their this, that's, and the other things. It really, the only thing I could do to save you guys was to break it down to these couple characteristics that are distinguishing from each one. But otherwise, they are really kind of similar oddities. All right. Number 11. Number 11 always tests a little softer than it is. What they actually wanted you to do was test the hardness of one of those teeny tiny little crystals that fall apart when you drag the nail across it. You're like, oh my God, this is falling apart. This must be soft. Well, no, it's just not glued together very well. Remember when we talked about isolated chain and sheet structures with the silicates? This is one of those isolated. Those little tetrahedra just aren't bonded very well to the tetrahedra next to them. So they fall apart. You could have had the same effect by rubbing your thumb over the olivine, okay? It still would have fallen apart. What they want, like I said, is a hardness test on one of those little crystals, which you just can't do. So 11 always tests a little softer. It is olivine. I don't know if I said that by accident, or I don't remember if I asked you guys or not. But sugary green, it does vary, all right? Sometimes this looks like sort of pea-colored yellow, all right? Not to be gross. Sometimes it's a really dark green, almost black. But olivine green, all right? It's the green one. Now, yeah, I know this one here, photograph's kind of green, but it is nowhere near the same shade in person as this one here. Still silicates. We got one more silicate coming at you here. All right. Reddish brown, pseudo-crystalline. Boy, that doesn't sound like me talking. And not very vitreous. So, 12, what'd you guys call 12? Ooh, we're all over the board here. All right, garnet. Yeah, good. Yeah, 12 is garnet. All right, as I always say, a chewed up piece of root beer candy. It is by no means something you might see in a pendant or a ring or something if you went to the store. That is nicely polished up garnet approaching vitreous, okay? That is really seldom its natural state. And I was talking with one of the groups a little while ago about what resinous looks like. 12's a decent example of what resinous can be, all right? Best example of resinous is amber, but again, if you guys have seen amber, more than likely it was polished, either in jewelry or at a rock and gem show or some kind of shop or something like that. All right, and they're going to put out a nice, shiny, pretty thing. And that really, it just hits that vitreous a little bit. And like I said, it's not like these are totally dull, so I said not very vitreous. It can vary. But these garnets here, like I said, are not probably what you would have expected garnet to look like, short of maybe the color. So, all right, one more. I lied. We go through 13 with silicates. So one more silicate, and then we'll see a couple more a little later, but we'll leave silicates for a little while. All right, 13 was chert. Good. Chert and flint are very similar. All right, if you saw this and you thought maybe this is flint, or thought it looked like an arrowhead that you may have seen when you were a kid or something, you're right on all accounts. Generally speaking, if it's light colored, we call it chert. If it's dark colored, they call it flint. Why? Same reason with muscovite and biotite. Who the heck knows why they decided that 200 years ago? But they did. Chert and flint are even more similar. Okay? Slightly different origination processes. But this is usually made from compaction and piling up of a whole bunch of little dead sea critters. Okay? Usually seashells are made up of calcite, right? And that makes limestone. You guys either come in here knowing that or you'll leave knowing that because I talk about it a lot. Well, believe it or not, there are critters that are so small that calcite is too heavy for them to make their shells out of. So instead they have to make it out of silica because it's lighter. And those critters, when they die and fall to the bottom of the ocean floor and make some sludge, it hardens into chert or flint. So, not organic because once it dissolves and goes into solution and comes back out, it's complicated because minerals are inorganic. But the root of these is usually those critter shells. So neat stuff. All right. Leaving the silicates for a bit and moving on to the first metals. 14, 15, and 17 are your first metals, not necessarily metallic, as we said, but they are indeed metal. I don't believe we did 16, sir. Yeah. So it's just another example of one of these guys. I didn't think we needed 3 of them, so that's why we skipped 16. But 14, 15, and 17 are hunks of metal. And what we told you guys is that for the most part, you're going to need to recognize them based on their oxidation. Yes, one of them is more magnetic than the others, but you're not going to have a magnet on the test, or at least you're not supposed to have a magnet on the test. All right? So that won't be of much help. Now, there is one that stands out. The one that's called limonite is actually brownish instead of gray. So you got 2 gray ones and 1 brown one. That sort of helps separate them out a little bit. The brown one tends to rust to a Cheetos orange colored. So you got this brown and orange. That's limonite. Then one of the gray ones gets these little white bird poops on it. That also should be a good bit heavier, heftier in your hand. It's called specific gravity. Okay, that's magnetite. It's magnetic. It's got bird poop on it, and it's really heavy. Now, most of that doesn't help you guys online. I try to give a couple clues here and there, but again, I can't give you too much. And then the last one, still gray, but it rusts actually red. That's the only one that really truly is rust, as you guys know it. These are all oxidations, not rusts. But the hematite goes to red. Think hemoglobin, heme, blood kind of stuff. So that's that. So that being said, which one is magnetite, which one is limonite, and which one is hematite? Limonite for 13. What do you guys? 15. Limonite for 15. Yes, yes, and yes? Let's see. Limonite. Mineral is brown. Oh, hey, there you go. And dark gray. Yeah. With orange oxidation. Yeah, so limes and oranges. If you mispronounce this one, call it limonite instead of limonite. Remember limes and oranges? So it goes orange. I don't know. But it is just, it's the only brown one, an orange one. So what do we do with 14 then? Got a vote for magnetite. What else you guys think? Magnetite, group 1. You went with hematite. So you called 17 magnetite then? Which one was more magnetic? Presumably you thought 17 was more. So the most magnetic of the 3 is going to be hematite. Again, that won't be much help on the test because you won't have a magnet unless you sneak one in. All right. But in going through this stages, the one called magnetite, let's, make sure that's the magnetic-y one. So yeah, as it turns out, 14 is magnetite. I don't have a real good example of the what I keep calling the bird poop. You can see a little bit of the white right here, and as I'm pointing through with my mouse for you guys online, okay? It's unavoidable. These things have been sitting next to each other in a tray for 40 years plus, okay? Oxidation's going to jump just a little bit like, pollen does on your pepper plants. You might get a spicy one where you're not supposed to, and so on and so forth. We can't do a thing about that. But left on their own, generally speaking, and I will try to put on the test specimen, should I put out a magnetite, I will try to make sure that there's some very obviously white marks on it. I joke about the bird poop because that'll stick in your head better, but it really, looks like white out a little bit. So you'll see it. I used to have one that you could, I don't know if you guys still had the toy when you were kids. It was this, 99-cent drugstore toy, a bunch of iron shavings in a plastic thing with a bald guy, and you take the magnet and you put eyebrows on them and hair and everything. So I had a piece of magnetite with those little shavings on it, and over the years, you guys petting it, it just kind of all faded away. So I don't think you could buy iron shavings. At least I don't know where to buy them. So our magnetite doesn't have the fuzz anymore. Which leaves 17 to be hematite. All right. And we talked way back when we talked about doing the streak test, we said that really it's only beneficial to you pretty much once. And that's for this. All right. Because you take an otherwise gray rock, you drag it across that streak plate, and you get a red streak. That's how you tell it's definitely hematite. It might be magnetic, but not like magnetite. And for what it's worth, hornblende is often magnetic. 9, I think it was. So anything that has iron in it could be magnetic. The better question, and I don't have a grasp of this kind of knowledge, is why isn't everything that has iron in it magnetic? That I don't know. So I'm sure Google does, but. All right, so to recap, 14 magnetite, 15 hematite, 17 limonite. No, hematite, sorry, 17 hematite. 16 was another hematite. That's why I didn't give you one. So what did we do with 18? We told you 18 was a repeat. Group 4, what'd you call it? Which one? Hematite. Group 2? 18. What'd you call 18 group 2? Magnetite. All right, group 1? Hematite. And group 3? We put quartz, right? No. What'd you put? Limonite. Because you thought this was brown. All right. All right. So good. Well, we got a little bit of everything here. That's good. I'm sure there's a metallic limonite out there somewhere. It would be cool to see metallic brown. But this one isn't it. If you called it magnetite, I'm guessing again that you felt yours was strongly magnetic. All right? At least compared to the other specimens. This is indeed hematite. And it too would leave a silver and a bit of red in there. This is nature's glitter, by the way, if you guys get fidgety here in a couple minutes after we're still talking. If you rub this, you will get all kinds of nice little metallic flakes on you. They actually used to use it for makeup way back when. Like, Egyptian time kind of things. Yes. So, this is technically specular hematite, but we're not going to worry about the specular part. (14, 15, 17, and 18 are all examples of what mineral group? Oxides. Good. Remember, mineral group is half the test. These 14, 15, 17, and 18 are all oxides. Unfortunately, there's a lot of ways to fail this test. Okay? First one, obviously, is just not knowing anything. The second one is going to the library and making your note cards. We're going to talk about note cards in a couple minutes. Sorry. and recognizing every mineral, but not really worrying about so not making note cards, because note cards will help you, so ignore me. The second way to fail is going to the library, trying to be a good student, and you recognize all the minerals, but you don't remember any of their groups. That's still 50% off there. All right? The other way is actually making the note cards. This is where I was going with this one. But never going to the library. So the note cards are designed to help you remember the mineral groups and attach them to the names. But if you don't know what any of them look like, again, you're looking at half the points. So you got to do a little bit of everything on this test. You got to pull recognition in to see it, and then the remembrance of what group it's in. Note cards help a lot with the groups. These are and this works for Rome Library as well. They used to be where you'd go and check out books at. I haven't been in a library in a long time. But you got this sort of like the ladies at the smaller desk, the reference librarians, and so on and so forth. But there used to be a big desk right in front of the door there. They've got it behind. It's on reserve, so to speak. Okay. Please share, especially when it gets time to the test, close to the test. You have to look at it in the library. If someone else shows up, even if they're not in your lab, they're in the other lab, or they're an online student, or vice versa, welcome them, please. I had 2 girls come bawling before one of the tests in my office hours because some mean person was in the library and wouldn't let them look at the minerals with them. Oh my God, come on. So, be cool, all right? Share. And it's always better to study with people anyhow, and especially if you don't think you have anything to contribute, you'd be surprised, because you might have one silly little trick that helps you remember a specimen that somebody else doesn't have, and you'll probably pick up 3 cool ideas while you're there. I cannot overemphasize the importance of studying together for this thing. Both campuses have them. All righty. Continuing on our trend of metallic, let's look at number 19. If 17 wasn't shiny enough for you, 18 wasn't shiny enough for you. 19 totally is. All right. 19 is a great example of what cubic looks like. 19 is a great example of a high specific gravity as well. 19 is not a great example of a mineral to lick, to taste, or to chew on, though. We'll find out why in a minute. Some of them we do encourage you to lick. Not this one. What did you guys call 19? Galena, yeah. And what's the formula for galena? PBS. This is lead. Just touching it a few times in here is fine. All right? Don't worry. But you don't need to gnaw on it. Is it soft enough to write? I can't remember. I see you trying to write with it there. Yeah, it's no graphite. And that's funny because the graphite's the one you guys always worry about. You're like, oh my God, I got lead on my thing. It's pencil lead. Pencil lead is carbon. And actually, pencil lead isn't even carbon anymore. It wouldn't be hard enough, right? It's some weird little alloy, to borrow the word there. But yeah, so you guys always worry about 21 or whatever it is. 23 maybe. Forget what number it is. We'll see in a minute. But this is the one with lead in it. All right. We're not going to do mineral group yet. Bear with me. 20 is a legitimately tough one. You guys go from thinking it's a metal to thinking probably it's dark and soft and not metallic, and then there's cleavage all over the place on it. Eventually you get to the answer of what, though? How about this side of the room? Skip and sphalerite. Yeah. Yeah, it's sphalerite. So, ZNS, right? Yeah. So, I don't know if it's the zinc. In my brain, zinc's a metal. I don't know. It's a vitamin we need, right? Everyone needs to get a little zinc here and there. In my mind, zinc is sort of metal, and maybe that's kind of why it looks metallic. If it weren't so dang have a weird sheen to it, this again would be a great example of something that is resinous. All right. But boy, it's just got a funky shine to it. It's a lot of people mix it up with garnet on the test. And here, you're looking at 12, you're looking at 20. Like, no, this is definitely, maroon colored, and this one is definitely brownish orange, maybe yellow. But on the test, they get mixed up a lot. So as such, I put them next to one another. I try to at any rate. So you can see them, at the same time and say, oh no, this one's definitely redder than the other one. On paper, garnet doesn't have cleavage. This one does. Garnet's hard. This one's soft. But on the, the specimen, the practical, you guys don't, you're not going through a lot of that. You're just looking at them and freaking out. So. All right. 21. Online here, I have a picture of the nice, pretty cube. You guys had the grainy mass and the cube here on campus. If you don't have, there's only 3 cubes left in the box. So one of you right now doesn't have the cube. If you haven't seen it yet, do make sure you see it before you leave. I'd say this was a perfect example of cubic cleavage, but what is this called? What mineral? Pyrite. Pyrite doesn't have cleavage. Instead, it grows. Yeah, that's the grainy mass. So at group 1, could you show them your cube real quick so they can... Nope, the other one. The shiny, looks like a dice. That means somebody didn't take one. Group 2 is offering theirs. So there must be one still sitting over there. Pillay, you want to grab it? Out of 21, there should be a little, looks like a dice. Next tray over, I think. Golden square, golden cube. There you go. All right, so that's the only thing they do have a picture of on here. So why did I include this then? Well, believe it or not, pyrite does have cubic crystals. And this is why teaching you guys cleavage way back when was such a pain in the butt, because of course you could recognize a cube, but telling the difference between a cube that's a crystal a cube that's cleavage, and a cube that's cubic and cleavage, it's just too much. Now, these are cut, all right? These were cut in a lab before they were mailed out. If these were pure original, grew out in nature kind of cubes, they'd be $1 gajillion, even though it's just pyrite. It's just rare to get them like this. We gave you the cube so you could see what's going on in that little grainy mass that you got that isn't so shiny, that is just looks like, old hunk of metal. But it is pyrite, and it can be nice and shiny. On the test, I try to give you one that has a little bit of both going on, so you can just see that. What's the formula for this one? FeS, yeah, so iron and sulfur. So you got ZnS, FeS, and PbS. These three minerals must be in what group? The sulfur group, the S group. Good. I don't know if you know anything about alchemists and back in the days of Dungeons and Dragons and all that stuff, but one of the things that they say they used to try and do was turn lead into gold. You can turn iron into gold. This is a great example of it here, fake gold, right? So I don't find it too hard to believe that there wasn't a little of that going on. Somebody figured it out by accident one day. Lead to gold? Yeah, I don't think that would work. But what are the likelihood that people knew the difference between lead and iron, or at least most people knew the difference between lead and iron back then? Not great, right? So maybe there's something to that. Mix just the right amount of iron with just the right amount of sulfur, and it turns into these cool gold crystals. You've certainly seen stranger things in high school chemistry, right? I still remember that thing where you pour two clear liquids in and you get these big white snowflakey things coming out of it. I don't know if they still do that in chem class or not. But, so, it happens. All right, so 3 sulfur group so far. Well, I was close. Graphite's 22. All right. Super soft, super slippery. You guys at home, you're really missing out on this one. Getting carbon all over everything. And again, it is just carbon. It's not lead. It does have cleavage. All right? I think. It's just so dang soft. Yeah, 22 has cleavage. I thought so. It's just so dang soft that all the years of you guys scratching it and rubbing it and bouncing around in the boxes and everything, it's just it's obscured on the edges and you can't see it. This has the same sort of cleavage as your micas did. All right, sheets. Seeing as it's made out of only one ingredient, carbon, it must be a member of what group? Elemental. Good. It's our first elemental, I believe. Speaking of elementals, what is this powdery yellow one? Sulfur. Good. 23 is sulfur. Please don't put sulfur in the sulfur groups. It always makes me sad, but I will mark it wrong. All right. It's much more important that sulfur exists on its own in a big hunk like this than the fact that it happens to be sulfur. Some of you were disappointed maybe that it wasn't as stinky as you'd hoped. If you use your fingernail and you scratch off a fresh chunk there, you will probably get a little bit of smell. All right, so far 2 elementals, but we're moving on to 24, which has no description for these poor online folks here. It is sort of vitreous. It's not so transparent as some of the other vitreous specimens we've seen. In fact, it looks like a whole bunch of different tiny little mediocre crystals glued together. But it does have one other unique property other than being glassy-ish, is that it's pretty gray. So what did you guys call it? Smoky quartz, yeah. So return of the silicates, right? 24 smoky quartz. How this is different than 1, 2, and 3, again, is that 1, 2, and 3 were single crystals. All right, it might not look like a crystal when you're looking at that glob of rose quartz, but For lack of a better word, it was a single piece. 24 is dozens, hundreds, however many, grew together really closely. And because they were all grew in a cramped area, they didn't really get a chance to come out very nicely. So, like I said, when it hits the light, you turn it just right, you will see those little flashes. But otherwise, that's kind of lost. 25. 25 gets called talc a lot. Why? Why not, right? It's powdery, it's white, it's arguably sort of slippy in your fingers. And then somebody in the group says, but talc has cleavage. This doesn't have cleavage. Oh. So it's not talc, it's what? Kaolinite, yeah. So if you called it talc, that's a good wrong answer, but it is still a wrong answer. Kaolin is a thing, they use it a lot. They use it in plaster and whatnot. And I'm not going to go over and get them because I think they've been moved. So I ordered a bunch of, every so often I have to replenish the mineral stashes, right? So I ordered, amongst other things, and they come in a variety of things. You could buy them in bulk. You could buy big hunks and break them down to make smaller hunks. Obviously, the nicer, the smaller you get them, the more they cost. So I was trying to save money one day, and I bought a bulk thing of kaolin, and I should have known when it came in kilograms. So this stuff shows up, and I ordered kaolin, not kaolinite. This stuff shows up, and it looks like I had 3 kilos of coke in this box. I can't believe it didn't get stuck at security somewhere. But it was just stuff that they used to make the drywall board with, like in plaster and stuff like that. But boy, it looked hilarious. I had to, because I opened it in front of the class and everything too, and I was like, what the? Good Lord. So that was a waste of me trying to save money. What's the formula here? Not that you guys know what Coke looks like, I'm sure, but you've seen it on TV. Aluminum, sulfur, oxygen, and hydrogen? In that order? Okay, good. Okay. What mineral group then? Yeah, this is what we call an aluminosilicate. We're not going to worry about the alumino part. But to the folks, again, in the mineralogy realm, that's important enough that they make note of it. It might even be hydroxylated. I can't remember if OHs or HOs are hydroxides. Might even be a hydroxylated aluminosilicate. But nonetheless, kaolinite. All right, kaolinite. 26, 27, and 29. For many groups, this is the bane of your existence. Unless you just break down and lick them. All right, and I get it if you don't want to lick them. And you folks online, don't lick your monitors. It won't help. Let's forget about 27 for the moment, and I want you guys just to take 26 and 29 and put them next to one another on your desk, and make sure they're standing up on their long ways, so they're in portrait mode, not landscape, so to speak. All right, we want them standing up nice and straight. The other way. There we go. All right, so they're nice and tall in the middle of your group's table so everyone could see them, and not at all like I took this picture here, but this picture was to get a good angle, not to compare 27 and 29. So what do you notice when you guys here on campus, when you put them right next to one another? Yep, I see one set of arms doing what's going on here. What do you see? One of them is nice and flat and straight, okay? And the other one's got a big old lean to it, hopefully. So one of these displays cubic cleavage, and one of these definitely is slanty cube or rhombus. Okay? Which one is cubic cube? 27 or 29? I'm sorry, 26 or 29? 26 is cubic cube? All right. So 29 then is slanty cube? All right. Remember, no math requirement for this class. The real names, of course, are cubic and rhombic. So otherwise, other than being one is very right-angled and the other not so much, All right. These guys are both more or less clearish, whitish. They're both soft. They're both arguably crystalline. Does this sound familiar? On the very first day when we sat here and talked about cleavage, I told you, really, you only need to use cleavage one time on the rock test. I'm sorry, on the mineral test. All right, it's for these two to tell them apart, unless you're going to lick them. All right? Because if you lick them, what would taste like what? All right, the one that we call halite would taste like salt. Is that the cubic one or the rhombic one, just for putting stuff together here? The cubic one ought to taste salty. Someone want to tell us if the cubic one tastes salty? Group 2 licked it. All right. If you're stuck on the test, I'd lick it. I mean, I'm sure you've put worse things in your mouth in your lives. So, at any rate. So, yeah, halite tastes salty. Halite is cubic. All right? Whether you go to the dollar store or McDonald's or you buy, a nice blue can of Morton's, no matter what you do to salt, it's always perfect little cubes. And you're thinking, wait a minute, my mom bought this awesome thing of pink salt from TJ Maxx, and that is not cubes. Yeah, you're right. All right, but that's a function of how it was made. All right, if you broke up those crystals a little bit, they should go to cubes. But yeah, I think that's because it was like evaporated, and then they get these big things, and then they break up those big things into these random hunks and then throw them into giant hoppers and everything. Those are severely weathered, believe me. But if you got fresh angles on those, they should. That pink Himalayan salt, purple Himalayan salt, all those wonderful varieties of salt out there. So what number is halite? 26. Okay? 26 is halite. What mineral group is halite? Halite is a halide. Another one I really hate to mark wrong, but sometimes I have to take half points off. Don't call this halide and say it's in the halite group or halide and halide group. Halide is the group. You have another mineral that's a halide, so hopefully that'll help you separate it out, okay? So what'd you call 29? I know, that was giving you guys a lot of stress over here. I didn't hear it. Calcite, group 4. All right. Similar. Calcium's the element. Calcite is calcium, carbon, and oxygen. Question? We'll get into 27 in a minute. There's a good reason. That's a good mistake. All right. So calcite. Calcite is rhombic. Tries to be at any rate. There's a lot of variation in calcite. This is the one, again, if you remember, sometime in science class in your past, your teacher said, hold this one over that typed letter on your book, and it inverts it, and you see the E upside down or whatever. There's some weird prismatics going on with this. Ours don't really do that. But we do try to put out specimens, and definitely on the test, try to put out specimens that are at least rhombic. And they don't taste like salt unless the person before you was really, really nervous. All right. Anywho. Calcite is a member of what group? Carbonate. Good. And you're one and only carbonate. Back to 27. It's funny, when you're doing, I forget if it was 7 or 8, whichever one muscovite was, a lot of you are damn determined that it's gypsum. And then when you get to gypsum, 27, you're damn determined that it's muscovite. Hopefully now that you see muscovite, you know you're reinforced that it's got a different look to it. All right, it's for lack of a better word, it's creamier. A lot of people say muscovite reminds them of coffee with cream in it. It's just got a different look to it. Yes, the cleavage is very similar. I don't disagree with you. All right. I mean, it's exactly the same. This is the same cleavage that the talc had, but the talc was so soft that you couldn't even see these edges. You could also argue that this is sort of cubic because you see like these little stair-steppy things on it. Just because of the way but it isn't. The cleavage here is the one directional. The problem with gypsum, 27 is gypsum, by the way. All right. The problem with gypsum is that it's fibrous. And because it's fibrous, it tends to break kind of really funky. And the pieces, I don't know if it's just, again, how they have to cut them in the lab before they sell them to the warehouses or whatever. They tend to cut them on the diagonal, which lends it that rhombic look. So it's a really confusing one, because if you look at the flat surfaces, you're going to see little stair steps and want to call it cubic or something like that. If you look at just the outline of it in sort of a 2D realm, it has the shape of a I guess it'd be a parallelogram at that point. I don't know. It's been a long time since I had geometry. But like a 2D rhombus. But the important part is that it's stacked. It's layered. Okay? So I don't have a good way for you to remember that other than me cautioning you and warning you that the piece on the test is definitely cut on angles. But as a whole, it just doesn't really look like a rhombus, and I'd like to think that the layering is much more prevalent than the fact that it's a little slanty on the ends. What mineral group? CaSO4, right? I don't remember a whole lot of formulas, but I think I know this one. CaSO4? Yeah. I have no idea why I know that, other than I've been doing it for 25 years. But I couldn't repeat orthoclase if I had to. So yeah, this is sulfur group. Calcium, sulfur, and some oxygens. Almost done. What do we do with 31? What do you guys call it? Amethyst. Nice. Group 2? Fluorite. Group 4? Labradorite. Interesting. All right. And ran out of timonite. All right. So. All right. So, group 1, you stop doing hardness tests. It is purple, but it is like a 4 in hardness. And it has cleavage. And amethyst doesn't have cleavage. It's just shiny, pretty purple quartz. Fluorite people. Yup. Hopefully you guessed that on not a purple one. Because you guys do tend to remember these as the shiny purple ones. Okay? I will do my best to not put out a purple one on the test. I do have some really cool, yeah, it is fluorite. And write it, I don't count spelling, but do go F-L-U-O. It's not flowerite. Don't go F-L-O-U-R. It's fluorite. This really stresses you guys out because it's not one color. And the color spectrum ranges from dark to light, and you never really know what to do with it. And I get it. These two are resinous, and you will never see this shined up and used in jewelry because it is just too soft. Okay? I think it is a 4 or 3. It's not very hard at all. You can't get it with your fingernail, I don't think, but it's not going to scratch a penny either. Cleavage out the wazoo, all right? But colors, they're all over the place. And it's just, some impurities that they don't bother counting in the formula that change it. I've got a really cool one that kind of looks like I think they call it ombre nowadays. It fades from a dark to a lighter color. It goes from a purple to a blue, or it goes from blue to purple. I forget which way it fades. Really cool looking. I've got some very pretty green ones that I tend to put out. So this online picture, for once, is actually a good bit better than what you guys got, because it does show a greenish one, and then we got a couple shades of purple. I don't know what this one down here is trying to do. But purple is most common. But fluorite is a member of what group? The halides, yeah. So fluorine is in the halide group. Same reason halite, which was NaCl, right? Cl is in the halide group, periodic table. That's why these are halide minerals. 32. What do we call it? Talc, 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 and talc, and talc, and talc. Yeah. Once you figure out that the kaolinite isn't the talc, and you remember the whole cleavage thing, this one kind of ends up going that way. These are some grubby looking. You always ask me what's a good example of earthy. This is earthy, okay? The one caution, all right, and I don't think, does anyone have the really hard white, almost looks like a white hornblende. It's got long crystals in it. It's really hard. Yeah, group, pass that around, please, actually, if you don't mind. So it looks like white hornblende. It's not as soft, and it's nowhere near as slippery as the other talcs, but it is still talc. So the fact we use talcum powder has nothing to do with the fact that it's, powdery and soft, going back to, you guys mixing it up with kaolinite. It actually does have a lubricative. Can I conjugate as such? I don't know. A lubricative property to it. It is slippy. That's why we use talcum powder. All right. One sec. Yeah. So that's why they like talc. So if you're confused on the test, rub it between your thumb and your pointer finger for a couple seconds, and you should warm it up enough, even if it is that hard white one. All right. Make sure group 3 gets their hard white one back. It is definitely going to get slippy for you. Yes, ma'am. Oh, okay. Group 1, can you share yours with them? So totally different appearance, right? But it's still slippy. Still slippy. Mineral group. Silicate, yeah. So in group 3, actually, you should see one of the other ones, so you don't know just that one. So silicate, yeah, I forget what all's in this one. This might be the hydroxylated alumino one. I don't remember. Oh, see, I was wrong. Okay. All right, last but not least, 34. I always love it when you guys do the hardness test. And who won, the penny or the copper? Well, yeah. Usually it takes off. This usually will scratch the penny a little bit. Not sure what that says about the diminishing quality of the copper content of our pennies, but more than likely you're just taking off some oxidation and grunge on the pennies. But this is another example of lab guy failure here. This is back in my first place I taught, and they didn't have any specimens, so I totally got to stock my lab for the first time ever. What's the hardness on copper? 3, right? So, like I said, the bigger you buy it, the less processed you buy it, the cheaper it is. So I could have bought, 5 specimens of copper for $100 or a pound of copper for like $20. I'm like, well, hell, I'll just do this and break it into small pieces. So I get this beautiful looking piece. I hope it's still on their shelf there, because I never could cut through the damn thing. All right. It's a 4. It's a property called tenacity. Okay. Just like they say steel is really, really hard, but it's brittle. Copper is actually quite soft. But I had practically channel locks trying to cut this stuff, and I couldn't get through the damn thing. And my dad was a pipe fitter. I should have known, or at least asked him, because they work with copper pipes all the time. And if you've ever worked with copper pipes, you've got to take this weird little pizza cutter looking tool, and you wrap it around it slowly but surely, get into it, and then you tap it off at the. Yeah, I didn't pay any attention, So it was a beautiful piece of copper, but we never got samples out of it. So. Something that's soft. So I'm just going back to these properties. Sometimes they can be a little misleading. If we say something's very, very hard and then, it cracks. Well, wait a minute. And in this case, it's pretty soft, but I couldn't cut through it. So, copper's a member of what group? Yeah, so sometimes you want to say oxide because you're going to see a little green on it, right? And, the Statue of Liberty's green, or if you've seen a copper roof, or maybe you have a copper pot or two at home. I won't mark it wrong. But we do like to see copper in the elemental group. Yes, it's going to oxidize. Why do we make an exception with iron oxide with the irons? I don't know. Okay. Again, I'm far from a mineralogist in my specific studies, but they did make an exception, and I'm respecting that because I don't know any better. But yeah, copper should be under the elementals because it's composed of a single ingredient, ideally, called copper. So what do you do with all this? Well, like I said, you spend some time. I'm giving the online folks an extra week, so I'm going to give you guys an extra week. We will not have the mineral test next week, unless you want it. If you're worried that you're going to lose this stuff in between. But what we'll do is igneous rocks next week. Igneous rocks are made of minerals directly, okay? So we'll be moving on, yet still remembering a little bit about minerals. So I want you to make note cards. Don't start putting your stuff away yet. We're not done. We're almost done. What? Talcs of what, you guys? What mineral group? Somebody's asking. Nope. This is why we don't put our books away. Talc. Silicate. I thought so, but I didn't want to, from memory, say the wrong thing. Any other? That's a great thing before I move on. Any blanks? Mineral name, mineral group. You got stuff in the middle, you can fill that in on your own. But any number, not have a name or a group at this point. Unless you weren't here for 2 weeks and you catch up. But anybody else? Okay. Because this is your answer key. This is your study guide. And from this, I want you to make these flashcards. For the folks online, I'm trying out making it an assignment this year. They're actually going to take pictures of them, turn them in, so on and so forth. You guys, I'm telling you, it works and you ought to do it. Okay? Use colored cards. Go to the store, buy a pack of multicolored cards. Why? Because we're going to use the colors for the mineral groups. Help your brains out. Put the sulfurs on the yellow cards. Put the oxides on the orangey pinky cards. Put the, whatever. You have to put silicates on white. You're going to also have to buy some white cards because there's not enough of any color usually for the silicates. We're going to use these again for rocks, so it'll be a good investment for you. And it's a flashcard. Think quick, all right? You're not filling all these properties out on these things. On the front, the blank side, just write the mineral name. On the back, put a couple things that you think will be helpful about it. A couple properties that will be helpful for you. The main goal of these cards is to attach names to groups, and that's why we use the colors. I recommend you get the cheapie cards, not the spiral bound ones, because we kind of want you to shuffle these, okay? So when you're going through these and you see a yellow card coming up, your brain is already saying, okay, this is a sulfur group. I don't know what the word is yet, but it's a sulfur group. And you see, oh, it's galena. It helps. I've had people tell me literally they could see the color of the card when they were trying to remember the damn name, but it works. Question? Yeah. All right, so we'll get there. We'll get there. All right, so that's how I want you to spend your time. And again, when you go to the library, if you go to the library, don't sit there and just look at these in order every time. Group them together by color and so on and so forth. Okay, do mix them around a little bit. Again, that's one of the difficult things with them online. You can't really shuffle them. I've had people tell me, my daughter was making them the other day, digital note cards nowadays. I don't know how useful they are or aren't, okay? What? Well, yeah, I know, 21st century, but still, sometimes you just can't beat writing down. And like I said, the colors are important. So if you could color code them, maybe. Give them a try if you want. But the better question is can you do them on your phone? And that's the thing, because you want to be able to just throw these in your backpack or in your back pocket, and when you have 5 minutes free, you go through them. If you just make them and never look at them again, it's still better than not making them. But ideally, you make them and you look at them. So questions about the flashcards. I strongly recommend it. Use colors for groups and keep it basic. I don't recommend putting pictures on them. A number of you taking pictures. We'll talk about that in a moment. printers suck is the main reason. And also we don't want you getting used to looking at just one image. So, if you're going to take pictures, I really don't recommend doing it in here off these shiny black tables, or as I saw some people doing in their hands and so on and so forth. Set it up right. Pretend it's an actual photo shoot. Put something matte behind it. Okay. The back of your notebooks, if it's brown, that brown cardboard is really great. It works for lights and darks. Otherwise, do it up even more proper and, put the dark stuff on white. Put the light stuff on something dark. I wouldn't use flash. And I would do it at the library where you have some time to actually think about it. But even then, if you're in night mode and you're not thinking about it, it's going to be a different color and so on and so forth. I really don't recommend studying pictures. And if you want to study pictures, I already have some mediocre ones on the web for you, which I am working on. All right, back to the test itself. Yes, there's 25 because we want a 50-point test. Yes, that means there's arguably 6 or 7 of them that aren't going to show up. And no, I'm not going to tell you which 6 or 7 aren't going to show up. All right. I can tell you that the test will be consistent if you guys are getting the test first. So I don't mix them up. Monday, you say, oh, Monday got harder ones than Wednesday got. Or no, if I pick something, that stays for the whole testing cycle. So I try to give you as many easy ones as I can, but with that many of them, you're gonna have some hard ones in there too, obviously. So what else? All right, many of you are already doing this, but please make sure you filter the rocks back into their trays. Take the time to make sure they get into the right trays. I got to take attendance still, but otherwise, and next week, at least this semester, for those of you that I might be recycling this video in the future, at least this semester, fall of 24, we are going to do igneous rocks next.